Labels and selectors are the core grouping mechanism in Kubernetes. A label is a key-value pair attached to an object like a pod or a service. They are not unique. Many objects can carry the same label. Labels let you organize and select subsets of objects in a meaningful way. Unlike annotations, labels are used to identify objects, not to store arbitrary metadata. Labels are attached to objects at creation time and can be added or modified at any time. Label keys have two parts, an optional prefix and a name, separated by a /. The name must be 63 characters or fewer, starting and ending with an alphanumeric character. The prefix, if given, must be a valid DNS subdomain of at most 253 characters. If the prefix is omitted, the key is private to the user. The Kubernetes EO and K8 EO prefixes are reserved for Kubernetes core components. Label values must be 63 characters or fewer and may be empty. Kubernetes defines a set of recommended labels to describe applications. These use the app Kubernetes EO prefix. Common recommended labels include app Kubernetes EO/name for the application name, app Kubernetes EO/instance to uniquely identify an instance of the application, app Kubernetes EO/version, app Kubernetes EO/component, and app Kubernetes EO/part of. App Kubernetes EO/managed by describes the tool used to manage the application, such as Helm. Using these shared labels makes it easier for tooling to work across different applications. Label selectors are how clients identify sets of objects. The API supports two kinds of selectors, equality-based and set-based. A selector can contain multiple requirements separated by commas. All requirements must be satisfied for a match. The comma acts as a logical end. Equality-based selectors use the operators equals, double equals, and not equals. For example, environment equals production selects objects where environment is production. Environment not equals car excludes objects labeled car. Both equals and double equals mean the same thing. Set-based selectors use the in, notin, and exists operators. Environment in open paren production. Car close paren selects objects where environment is either production or car. Tier notin open paren frontend. Backend close paren selects objects where tier is not frontend or backend. The exists operator, just the key name with no value, selects any object that carries that label key. An exclamation mark before the key means the key must not be present. Set-based requirements are more expressive than equality-based ones. When listing resources with kubectl, you pass selectors using the -l flag. For example, kubectl get pods L environment equals production, tier equals frontend. Set-based syntax works too. Kubectl get pods L environment in production, staging. In API calls, use the label selector query parameter in the URL. Services and replication controllers use label selectors to target pods. A service routes traffic to any pod matching its selector. For example, a selector of app equals my app sends traffic to all pods labeled app equals my app. These older resources only support equality-based selectors. Newer resources like deployments, replica sets, daemon sets, and jobs support set-based selectors. Their selector field uses matchLabels for equality requirements and matchExpressions for set-based requirements with operators. In, not in, exists, and does not exist. All matchLabels and matchExpressions conditions are embedded together. Labels and selectors are the foundation of how Kubernetes groups, targets, and routes workloads. From services to deployments, everything relies on this simple but powerful key-value system. That is labels and selectors straight from the Kubernetes docs.